Thank you for listening. Today, I'm sharing the results to date of a survey that we refer to as the Basic Geo 1, where Basic stands for the beliefs of students in introductory courses, and Geo refers to the discipline in which we're exploring those beliefs. This survey is an application of Eisgen's theory of planned behavior, and our hope is that it and its end-of-semester partner survey can serve as tools to better understand recruitment and retention efforts in our introductory courses. We've undertaken this study for several reasons, the first of which is that introductory geology courses serve as important training grounds for earth science literate citizens, as well as opportunities to recruit majors to traditionally small and non-diverse programs. Most of the studies looking at why students are attracted to geology have come from majors or even graduates, who are temporally separated from the beliefs and decisions that would have led them into the field, which this study seeks to address. Beliefs in aggregate can provide the cognitive and affective foundations for how we feel about a behavior, as well as our intent to engage in that behavior. Finally, having more reliable and validated instruments answers a repeated call in deeper. Together, the basic geo surveys, which measure the extent to which different beliefs drive enrollment in introductory geology or intent to pursue a second geology class, can help us evaluate recruitment and retention efforts to and from our introductory courses. We have grounded this study using the theory of planned behavior. This theory predicts that planned human behaviors, such as enrolling in this geology course this semester, are guided by intent, which in turn is influenced by behavioral, normative, and control beliefs. It also acknowledges that this intent can be intercepted by actual behavioral controls that are potentially out of the student's ability to manage. Behavioral beliefs are those about the likely outcomes of the behavior and the evaluations of these outcomes, which might include beliefs that the geology course will be interesting, fun, easy, or relevant to the student's career interests. In aggregate, these behavioral beliefs shape attitudes. Normative beliefs are those about the normative expectations of others and motivation to comply with these expectations, such as those of parents, advisors, or friends who do or don't value the student taking this geology course. In aggregate, these normative beliefs shape subjective norms, which an individual may be more or less susceptible to, for example, valuing the advisor's input more than a parent's. Control beliefs are those about the presence of factors that may facilitate or impede performance of the behavior and the perceived power of these factors, such as the time and format of the course, or a student's perceived ability to enroll that semester in general. The aggregate of these control beliefs represents an individual's perceived behavioral controls. If accurate, perceived behavioral control can also serve as a proxy for actual control and contribute to the prediction of the behavior in question. Together, these three sets of beliefs drive an individual's attitude towards the behavior, the degree to which an individual perceives and responds to social pressure, and their sense of perceived behavioral control. The more positive each of these factors is, the stronger an individual's intent to perform the behavior in question. This study followed the two-phase qualitative and quantitative design suggested when there is a limited understanding of the beliefs that drive the behavior, in this case, enrolling in an introductory geology course. We began with an open-ended survey of student beliefs, paired with some demographic questions. To establish initial face and content validity, the survey was reviewed by two groups of students and faculty familiar with the course. Based on their feedback, the survey was revised and administered in spring 2019. Authors 1 and 2 conducted a thematic analysis of open-ended responses about beliefs and used these to generate a preliminary pool of 40 semantic differentials. For example, this geology class is much more or much less interesting than other lab science courses like chemistry or biology, to which students responded using a 7-point Likert scale. These survey items were again reviewed by students and faculty, which resulted in some wording changes for clarity. We disseminated the revised survey with the 40 items plus demographic questions to 535 students in introductory geology courses at a large public research university in spring and fall 2020. The data at this point were randomly split in half for exploratory followed by confirmatory factor analysis, in which the data met appropriate assumptions for this process. Before I go on, I do want to acknowledge an important limitation here, which is that this data has all been collected at one research university, which we would like to address. If you'd be interested in sharing the basic geo survey I'm describing today with your intro students this spring, I'll have my contact information on the last slide. We had an average response rate of 60% for the different iterations of the survey, including 755 students who gave consent and provided demographic data. Note that all of these did contain a prefer not to say option and, except for the age brackets, an other option with a chance to elaborate. Students responding to the survey were broadly representative of the university at large in terms of age and racial or ethnic makeup, though proportionately more male. The students are mostly traditional age college students, predominantly freshmen and sophomores, and mostly non-Hispanic white. The initial belief solicitation survey included 9 open-ended questions following formats recommended in other elicitation studies. Each of these explicitly includes the behavior in question, that is, enrolling in this geology course this semester, highlighted in red. Each set of questions has a positive and negative version of each other, advantages and disadvantages for behavioral beliefs, approved or disapproved for normative beliefs, and easy or difficult for control beliefs. The normative beliefs questions also got at who students viewed as likely or not likely to enroll in this geology course. The goal of these prompts is to generate what are known as the modal and accessible beliefs of a group about a behavior. These are the ideas that are both the main factors to which students attribute their beliefs and those which they're able to recall. A natural limitation of any belief study is that humans are not always able to explain all the motivations for our own behavior. Feedback from the student expert review panel suggested that survey burnout was a significant threat to survey participation. Therefore, we set up the survey such that students would get behavioral, normative, or control beliefs questions based on the first letter of their last name. Though we attempted to make these groups as even as possible, we did receive more responses from students with last names beginning with A through E responding to the behavioral beliefs questions. Students could write as much or as little as they wanted, and responses ranged from a few words to several sentences. The two authors conducting the thematic analysis reached data saturation for each of the beliefs sets prior to analyzing all responses, though all 698 responses were eventually examined, suggesting that the number of responses was sufficient to capture the modal and accessible beliefs of this group. From this analysis, we generated a list of semantic differentials representative of both consistent themes and negative cases. Here are 6 examples of the 40 different semantic differentials we developed based on student responses. Items were selected to capture different types of beliefs. For example, not only normative beliefs, such as whether my peers would approve of my decision, but also the extent to which the individual was prone to act based on that approval. Items related to each belief construct were randomly ordered, and positive and negative endpoints for items were also randomly assigned. Each of the initial items was reviewed by the authors for readability. Based on feedback from the 2 expert review panels, an attention check question was added about 2/3 of the way through the survey, asking participants to select a particular response to that item. This response, along with consent, were used to screen surveys prior to the initial factor analysis. Before we began the factor analysis, we confirmed that our sample size was sufficient based on the minimum recommendations of 300 respondents and a person-to-item ratio of at least 8:1. We next confirmed that the data met criteria for both the Kaiser-Meyer-Olkin measure of sampling adequacy and Bartlett's test of sphericity. We used the SCREE test to determine the number of factors supported by the resulting matrix, which turned out to be 5 factors during each of the 3 rounds of EFA. We expected some correlation among factors based on the original theory of planned behavior. For example, subjective norms may influence attitudes and control beliefs. Therefore, we elected to use an oblique rotation method. A Promax rotation with a 0.4 loading cutoff was used, and the pattern matrices were examined for factor and item loadings. This approach initially explained 43.2% of the variation and produced no cross-loading items, though 11 items did not load onto a single factor and were subsequently removed. The EFA was reran, resulting in all but 1 item loading onto 5 factors. After one more iteration, the remaining 28 items each loaded onto a single scale with a factor loading of greater than 0.4. This final analysis with the 5 factors explained a total of 52.6% of the cumulative variation. The 5 factors identified by the EFA, along with the variance and the number of items included is shown here, as well as our current name for the factor. Though internal consistency is not a requirement of salient belief composites, Prompax alpha for each of the scales range from just under 0.5 to 0.772. Though the first factor explains the largest amount of the variance, it has also not been as strongly supported by a subsequent confirmatory factor analysis, so I'll start by walking through the other 4 factors in reverse order. These 4 factors all have items that, as latent variables, have loaded significantly onto their factors in the CFA. Factors 4 and 5 are autonomy and the professor, each of which had 2 items. Autonomy refers to whether or not the student was able to choose to take a science course, and specifically a geology class, and is a type of perceived behavioral control within the theory of planned behavior. Students reported the professor generally had a significant role in their taking this geology class, and reported taking Rate My Professor or similar review systems into account when signing up for the class. Interestingly, 2 other items related to the degree of caring and challenge demonstrated by the professor did not load onto this scale, suggesting there is something else the students have in mind when considering the professor. Factor 3, students like me and the other class, included 3 items that have to do with what other people think of the course and their enrolling. We interpret the people in my life here as students first because it is reasonable that this is who students have in mind when considering who else would take this class, but also because other items beginning with the people in my life loaded onto factor 1 with items about authority figures like advisors. The other 2 items compare this course to other lab science courses, describing it as more fun and interesting. A similar item comparing the level of challenge of the lab science course failed to load onto any of the factors, suggesting that perceived ease is not a central factor driving these students towards geology over other lab science courses, contrary to some previous studies. The first part of the scale here is aligned with the theory of planned behavior's subjective norms, and the second part with attitudes. Factor 2 has 8 items encompassing 2 themes: personal benefit, which included earning general education and lab credits, and the benefit to one's career. The second set of 4 items all had to do with learning about geology or feeling more connected to the Earth. Interestingly, an item about having had previous experience with taking geology or earth science courses did not load onto this factor. These would all fall under the category of attitudes within the theory of planned behavior. Factor 1, which represents 22.9% of the variance explained by our model, has proved to be the trickiest to explore in the confirmatory factor analysis. Tentatively, it appears that there are 3 sets of items within the 11 loading on this factor that align with the theory of planned behavior. The first 5 relate to attitudes students have about the geology course, ranging from their success to enjoyment to the degree of caring illustrated by the professor. The next 3 items relate to students' perceived behavioral control, that is, the degree to which it was easy or difficult to sign up for the class, whether that was due to a complicated enrollment system or other factors altogether. The last set of 3 items concern subjective norms. These suggest that it is important for students that people who influence their behavior and whose opinions they value would approve of their decision to take this course. We interpret the people here as advisors, as this was the most frequently cited group of influential individuals during the open-ended portion of the study design. Though there is still refining to be done with the CFA, we are pleased to share the development so far of the basic GEO, or beliefs of students in introductory courses in geology. This spring, we want to expand data collection to other institutions, as well as to other science disciplines, to explore the beliefs that drive students in different environments and courses. We are also in the process of refining the basic GEO 2, which assesses beliefs that drive intent to pursue a second geology course, in its 3rd cycle of testing this fall. Together, we believe the basic GEO 1 and 2 can serve to measure the success of efforts to recruit students to our introductory courses, and from there to our majors. With that, I'll again encourage anyone interested in testing the survey in their own introductory class to contact me using the email address here. I would be happy to take any questions.